For my Patreon viewers, as promised, here is the assembly of that little FM low power transmitter kit, beginning to end, so you can see the amount of time it took, and I describe every part that I'm going to be putting into this thing again. This is for Patreon users only. Please don't share this link with others, and thanks for being a Patreon. It's let's build a kit tonight. Let's build a kit night. I just got this little package in from China, and it's a bag full of parts and a little circuit board. And what this one here is, we've seen this before. Of course, my camera is too close to focus. I'll just raise it up a bit so maybe I can get a bit closer up shot, or I can still reach it. This camera, I tell you, it's a great camera, but it doesn't focus that close. If I zoom in too close, it's not going to focus. So I'm trying to find a happy medium where I can still reach this thing without having to actually get up to reach it, and it'll still be relatively sharp. Anyway, if we look closely at it, this is using a BH1417F. I think you guys know what used that IC. This is the stereo FM transmitter board kit that I was telling you that I was getting. It's from EEQ Kit, and this thing here is probably going to be more to the liking of what I need for testing. Now this one here doesn't use an atmel to set the frequency. It's done by setting dip switches. So you can pick one of several frequencies for this. And what we've received is just a bag of parts. And as you can see, the silk screening here tells us what parts to put in to what places. So the first part we're going to install is going to be the surface mounted part, just because that's going to be the most difficult one to install. And it's the only, I think it's the only surface mounted part on this. So we'll do that one first, and then I'll start mounting the other components on here. So here's our IC. This is the one I'm probably going to need the most amount of help on, either by using my microscope here to inspect it, or my magnifiers, which I'll use to actually complete it. So let's get the IC in place, and we'll tack this one down. We'll start out with this IC and then start mounting the other parts. I'll just tack down one pin first to make sure that the rest of them are all lined up. Which they are. Now we'll do the other corners. This will hold the IC in place so that I can do the rest of them. Okay, now we'll tack down the rest of these terminals. Try not to bridge anything while I'm at it. Of course, I try not to bridge. That's usually when I'm going to bridge it. So to get that clear, we'll just put some rosin on there. And that should clean this up a bit and make the solder flow nicely. Just like that. Okay, that has the IC mounted. I think at this point I can probably go back to my regular tip. I put my fine tip on here. Maybe I'll use the fine tip. These are all very small components on here anyway, so I can probably get away with this one. Okay, well, I'll start mounting resistors. So we've got some, what do we got here? We'll start on the edge of the board here, I guess, and work our way across. We've got some 10K resistors to go in here. So that's brown, black, orange. So we've got 1, 2, 3, 4, looks like 5 of them. So 5 of them. There's 5 10K resistors right here. Nice thing about this kit is they're using the standard, not using precision resistors, so they've only got the 4 bands instead of the 5. So it makes it really easy to figure out the color codes, especially for someone like me that's old school. When I was in the business, there was no 5-banded resistors, there was no precision resistors. All we had was the standard color codes. So it was easy. You didn't have to think about that third color and then the multiplier being 1 down, right? Of course, on a precision resistor, on these resistors, it's brown, black, orange. On a precision resistor, it would be brown, black, black, red, and then followed by the last band, which is usually brown on them for 1%. This one here, the last band is gold. So there's our 4 or 5 10K resistors. Then we'll solder those down. Okay, continuing with the 10K. We get all the 10K resistors mounted first. There's two more. No, there's one here. 10K and a 10K. There's two more of them here. Three more of them. So let's get those three mounted. Four of them. So there's one here. Another one here. Oh, better put that in the right way or somebody will jump all over me for putting one in the opposite direction, even though they're not polarized. The 10K here. And one more there. I'll shout out where this kit came from. This one came from IC Station. You guys already know that because I've already put their logo up here. But this is an IC Station kit. I have another one as well, but I won't tell you what it is just yet because I haven't built it. But I've got another one that I'll be doing very soon. That is another neat little audio accessory kit. It arrived at the same time, so I have it. I just have to build it. In case you're wondering why I've gone back to my electrician snips, they actually cut better than those side cutters. Okay, that's those 10K. There should be three more of them that goes on the board here. Let's find them. There's one over here. One more down here. And there's one last 10K. You see where that one goes right up here. This thing's got a microphone socket on it too, but I doubt that I'll be even bothering to attach the microphone because this is going to be used for generating an in-house FM signal for testing. Hopefully it's going to go a little bit further than my other one, but not have as much range as that one that put out 5 watts. 'Cause that one is just asking for trouble. I just need a signal that gives me a good quality signal that I can pick up around the yard for testing radios and stuff. Not something that I can broadcast to the entire community. And that other one into a proper antenna certainly would do that. But it's been it's gone to a new home now. I got a message the day after I put up the video showing it off, and one of the viewers asked me what I was going to do with it, and I said, well, I'm not using it for anything. And he asked if I would sell it to him. I said sure. So he made a donation to my YouTube channel, and I sent him the unit. Okay, that's those ones. Let's start finding other parts to put in here. 4.7K resistor. Let's see what other, well, we'll get the other ones here. These ones here, these ones are 2.2. So we'll do the 2.2s. I'm going to do all the ones that have got multiples. Get them out of the way. So here's the 2.2s. I generally find that that makes building kits a little easier. If you do all the like components, get all the ones that are the same value, that you've got multiple ones to do. Get all those ones out of the way first. Do the surface mount ICs first, and then do the resistors. Get all the like values out of the way, because the board gets easier to find the other components when there's fewer open spaces. So all the like ones, get them all taken care of, and the rest will take care of themselves, as they say. And it doesn't take long to put them together at that point. Now, as you can see, I'm putting this together without any manual, without any instructions, and it doesn't come with instructions. But you can certainly print the schematic off of the website, and you can print instruction manuals off the website, but I'm not using any. The circuit board is silk screened. It's really easy to figure out where the parts go. If you know your color codes, it's real simple. Okay, that's got those ones. Let's do the rest of the resistors. Got a couple of what are these ones here? 4.7K. There's two of them. So let's grab the 4.7Ks and get them installed. So 4.7K is yellow, violet, red. There's also a 4.7 ohm that goes on here as well. So 4.7 ohm is up here. It says 4.7R. And there's a 47K as well, which is over here, which is a different one. But here's our 4.7K. There's two of them. One goes here. The other one goes next to it. Right there. Since we're dealing with RF circuits on here, you want to make sure that your components are flat against the board. Okay, the next 47K, these ones are yellow, violet, orange. It's a 47K that goes right there. I can spot that one a mile away, and there's another one that goes right up here. And we got a 4.7 ohm, which I think is one of the last resistors. No, there's one more here, 100 ohms. 4.7 ohms, which is violet, purple, and this one will be gold for the third band, and that's listed here as 4.7R. Okay, and then there's two 100 ohm resistors. I believe that's the last of the resistors here. Brown, black, brown, 100 ohm. There's two of them. And they go, one goes here. The other one goes up here. So now we'll start the ceramic caps. They're marked on the board. C5, it's a 104, so 104 picofarad, so it'll say 104 on it. C3 is a 30 pico, so it'll have a little 30 marked on here. These ones all have markings on them. There's a 30 there. These ones, the polarity is not important, but it is important to get them low on the board. There's another 30. So we'll get these ones mounted. I'll mount these 3 first. Again, very critical to have these mounted as low, as close to the board as possible, because if there's any excess leads, they could cause radiation and interference to other circuits. All the leads in RF circuits are very critical that you keep them as absolutely short as possible whenever you're working with transmitters or oscillators in the VHF range. UHF is even more critical. I have built a few FM transmitters over the years. And the ones that I built years ago, and we're talking, 30 odd years ago, I built a couple that were sent up country and used as translator repeaters to pick or pull stations, local or distant stations, into a small town, and they were running for years. They may even still be on the air. I don't know, because I haven't been up there in a long time. Make things easier if I just turned all these caps over so I could see the values of them. Looking for the 104, there's a 104 right there. C12. Oops. There's another one here with 104 as well, wherever it did with it. There it is. I spotted it right down there. Okay. 222 and 101. There's the 222. And the 101. So there's a 101. .102. So 102 right there. Got a 30 picofarad. There's a 30 right there. Another 104. And another 30. A 15. Another 101. As the components get placed, it gets a little easier to, as you go to do this, because there's fewer and fewer components and there's fewer places left to mount them. So it tends to get faster as you get completed. But this is going together very quickly, this kit. We have 30. It's a 3. There's a 30 there. This is the antenna output, the coupled output. You know what I think is funny is I get all this stuff sent to me, and I have to. This one here comes into the mail, and I have to go to the post office and sign for it. It's like a $5 kit, and I gotta get dragged all the way into the post office, whereas I've had them leave stuff that's worth hundreds of dollars at the door where anybody can steal it, and they don't bat an eye. But I get a $5 kit, and I gotta sign for it, and because I wasn't here when the postman showed up, of course he wouldn't leave it, I had to go and collect it the next day at the post office. It's ridiculous, you know. And stuff like this, you could have shoved it through the mail slot and it probably would have fit. But oh no, got to be signed for. A $5 kit. You know, $100 radio, no, I'll just leave it at the door. Doesn't make any sense, does it? One's a 102 here. I think those days, though, are coming to an end because it just featured on the news that I think it was FedEx. Was it FedEx or UPS? They were going to, I think it was FedEx, they were going to change their trucks and start delivering in just nondescript white trucks, because I guess the bandits have been following the trucks around, and when they see them drop something at the door, the bandits have been going along and pilfering it. So it was just on the news that they were going to stop delivering stuff if there was nobody home. They were going to make you go in and pick it up first of all, but they were going to drive around in unmarked vehicles so that the bad guys don't know what's in the neighborhood. Just looking to see if there's any more. There's a few ceramics remaining. There's 2 of them here, so there's got to be 2 more on the board here. I'm just looking for it. Oh, there's one there, 22. There's a 22 there. And there should be one more ceramic cap. Oh, there it is there. Should be a 103. That's it, 103. So that's the last of the ceramic caps. So we're getting very close to being complete on this project, and I'll be able to test this thing fairly soon. Okay, that's it for the ceramics. Let's do the electrolytics now. What do we got here? 1 microfarads. There's a 1 mic there. These are polarized, these ones, so you gotta watch the polarity. It's a 1 and another 1 here. And 2 10s. There's a 10. That should be another 1 and another 10. There's another 1 there. Actually, there should be another 1 as well, and a 10. This one is a 1. So that goes in here. There should be 1 more 10, wherever it is, over here. No, that's a 47. Another 10 is, I think this is a 10 here. That's a 22. What is this one? Another 1. That goes over here. $22. 470. There should be a 10 somewhere here. I don't. Oh, there. Is that it? That's 47. Okay, the 47 goes in. Where does it go? 47 is here. And 22 is right here. 470 is up here. And there should be a 10. There should be another 470 here. Where's the second 470? There it is. And it goes down here, and then there should be one more left, which is the 10 microfarad, and I don't see it. Oh, there it is. That's the 10. Okay, good. There's all of our parts. And the 10 mic is right there. And now we'll solder these all down. Okay, that's got all the electrolytics are now mounted. Get the crystal in here. And yeah, some coils to mount. A couple different coils. Actually, there's 3. This one inductor, where does it go? It's a 1500 microhenry. That's this one here. Or sorry, 150 microhenry. Brown, green, brown. And that goes right here. And there's 2 other coils here that have to go in. I have to figure out where they go. There's L2 and 8 turns and 5 turns, it looks like. Okay, so that's 1, 2, 3, 4. That's a 5-turn coil here. And that would mean that this other one, which has got 8 turns on it, goes into this one here, L2, which says 8T for 8 turns. They've actually done a very good job on making this kit as easy to put together as, I mean, this is really simple. Hardest part to put on this kit was that SMD. If you can handle one SMD part, then you can handle this kit no problem. I should point out that if you're seeing the short version of this video, then you're not a patron. If I'm doing 2 versions of this. The condensed version is the public release, and there will be a full non-edited Patreon release also showing the placement of every component and all the testing and everything. I try to keep these videos relatively short because this is being done more as a promo for the for IC Station, but there will be a full released video of the same assembly, but like I did with the AM transmitter build, it'll be for patrons only, and it'll show the placement of every part, and nothing will be skipped, nothing will be cut out. So we've got a couple transistors now I've got to mount. It's got a 9014. What's the number on this one? That's a 9018. Where's that one go? 9018. Here it is. 9018 goes here. Another 9018 transistor. And this one goes this one down here, there's two of them. One there. And there should be another one. That's a 9014, so that goes over here. And the other 9018 is this one. Okay, what's left on here? An LED and a diode. Two diodes. Which ones are which? This one's marked a UD1. Can't see what that one says on it. A3 something. What's the other one? Zener diode 1, 4.3 volts. I think this might be this one. Something 3. Is it 4.3? It's impossible to read this. Okay, this one here is the FE1043. It's the variable diode. It's a voltage variable diode, and it goes down here. This is this one. Numbers are very hard to read. I had to use my microscope for that. And then the Zener diode is this other one over here. Only things left to put on this is a couple of switches, the LED and LED goes in there. A couple of little switches to go into this thing. Okay, there's a jack here. There are positive and negative terminals for hooking it up for power. And there's a switch that goes in here. There's two switches. Which switch goes where? I guess it doesn't matter. One switch goes here. One more little switch over here, which is this one. This is the switch between, I believe, the low and the high end of the band, because it can either work on the 88 or the 108 side. There's only so many frequencies you can set with the 4 dip switches. I think it's got 4 dip switches. Yeah. So there's only so many channels you can set. You either pick them on the low end of the band or the high end of the band. And this is the switch that selects which side of the band you're going to be on. The dip switches go here. The first transmitters I built the ones that went into commercial service, they all were set with dip switches. Because typically, you know, once you're set, you don't ever have to change it. You shouldn't anyway. And last but not least, the audio jack and the microphone. There's our audio input jack here. Installed the correct way, not like the other one where they bridged over the audio switched line, which of course made everything go to mono. We won't make that mistake on this one. We ground. And then the last thing is this microphone, which does have a polarity. But it also only goes in one way. It's kind of, the pins are off centered. So next is to hook up the antenna, get an audio source, and test it. So there's the microphone in place. Not much of an antenna. It will do for this testing, for sure. Antenna just goes over here. And we have our battery case, or we can run it with the power supply. I'll just test it with batteries because I've got them here. Got the battery case here ready to go. Let's hook up some power and test this thing. Okay, I've got it, all the switches are set low. That should be 87.7. I've got my radio tuned to 87.7. We'll just load up some batteries here and watch it not work. Well, the light lights up. Do we have any signal? I don't hear any signal. I definitely don't hear a signal. I guess we have to troubleshoot, see why it doesn't work. I wonder if these are backwards. If these switches are open, I'm going to have high, 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 high. So if I switch them all on, that's it. So they're opposite. Switches on to create low, off to create high. I've got my signal. Sounds nice and quiet. Let's see if it'll play music. I'm probably overmodulating here. I'll have to adjust the levels, but maybe not. There we go. Doesn't sound bad. schematic here too, so probably wouldn't be hard to increase the power on this thing. Let's see, S3. What's that doing? Okay, that's this one here. That'll change the band. Yeah, that changes the band. I'd probably change the value of R15. Wouldn't change the power a little bit on this thing. But it's doing the job. It's working. Sound quality is excellent. This is from Triple Scoop Music, which is a royalty-free company. We'll try some stuff from Music Bakery here. What am I going to play here? Lots of stuff to choose from. I'm thinking that noise is my other one. I'm going to just go unplug the other one that's on 88.5. Pretty sure that's one that's... Well, I thought it was, but I'm still hearing... very low power. So there it is. It's complete. As you can hear, it's pretty quiet now. I've got my other one still turned on. I plugged it back in. If I tune the radio down to 87.5, you'll hear my other one. And then this one. Running the same music. Anyway, that's it. It's all done. That's the little FM stereo transmitter kit from IC Station. Links on the page here. If you want one of these things, they're pretty inexpensive, fun to build, doesn't take long, and you know what? It works. We'll catch you later.